Okay, so we were finishing off with a hyperbola in the last one, and this one we're expecting to maybe get an exponential, but let's see what they give us. So we've finished with that question. We're going to scroll down. Y equals 2 times 3 to the x plus 1. Where is the x sitting? In the exponent. Hence, I was enjoying this bright pink here. Exponential is what it was. So it's an exponential function. So our most basic exponential we know goes like this and goes and flies up. In fact, we know a few more things about it. We know that it goes through that point 0, 1, and we know there's an asymptote on the x-axis at y equals 0. Now this one, what's it doing? It's first multiplied by 2. So this thing has been stretched from the x-axis, so it's stretched up. So that point, if your output's been multiplied by 2, we know that it's moved up here. So instead of at 1, must surely be sitting at 2, 0, 2. We don't need these exact numbers, but just think of that process. It's been stretched up. And then the plus 1 has said, let's move this whole thing up by 1. Asymptote, asymptote, asymptote. There was an asymptote here. So there must be an asymptote here that's moved up by 1. So y equals 1 is a new asymptote. It's going like that. It's cruising up. We know that it's got a y point 0, 3. But let's see. If we didn't know that it's 3, that's fine. But we've pretty much sketched our graph. So let's go through the things. It looks like there's going to be a y-intercept. For the y-intercept, we take our function, y equals 2 times 3 to the x plus 1. What do we know about our y-intercept? This time I'm just going to have these axes here ready to go so that we can jot down the information we get. Okay, well, at this y-intercept, the x value is 0, right? Always. So y equals 2 times 3 to the power of 0 plus 1. And you see why that idea of just substituting x equals 0 works so nicely, because it's just going to get us home all the time. So 3 to the 0, anything to the power of 0 is 1. And 2 times 1 is 2. 2 plus 1 is 3. But don't forget this nifty little tool as well. You can just type it in. 2 times 3 to the power of 0 plus 1 equals 3. Cool. Let's check. Oh, look at that. So 3 it is. But the numbers are normally small enough that we can do it without a calculator. But hey, use it to check. So therefore, remember, coordinates, when x is 0, y is 3. Okay, so we know that it's going to go through 3. We knew that generally there's an asymptote here. And we know that this plus 1 has moved everything up by 1. So the asymptote was here. Now the asymptote has gone along there. And it's at y equals 1 because it moved up by 1. And that's what the plus q does. It moves everything up by that value. So if it's negative, it will move it down. Okay, we've got this value here. What else do we need? This is a positive. So it's not like it's reflected. This number 3 is not a fraction. So it's going to stay this shape here. So we're going to do this and say, and we went for this lovely green. Let's go for a darker blue. Oh, there we go. Let's go for dark blue. We had the green last time, right? Let's keep our blues and greens in check here. So we've got our graph and we know the shape looks like. Oh, after all of that, I didn't choose the blue. I'm going to really push. I want this blue. There we go. Save. Blue. Okay. So we got our graph. We know its shape looks like this. Notice that I didn't put that y-intercept in yet because then I'm going to be forced to draw through that line. I haven't put -1, -2, -3. I'm interested in the shape and the important points. That's an important point. And I'm not thinking, oh, was it 3, 0, 0, 3? I can look across here. I wrote 0, 3, so it's 0, 3. There's our function. Last step, just so that it's nice to do. Y equals 2 times 3 to the x plus 1. Notice I always like putting that times. Often there's the dot. Doesn't really matter. I just like times as times as. Otherwise they look like 2, 3 or something. So I always write the times like that. There's our function. Looking good, right? So just to recap our sketching of functions. Think, what type of shape is it? Is it a straight line, parabola, hyperbola, or exponential? Once you know that, you've got an idea of what the basic shape is. Then just run through, I was drawing them as little sketches. I think that's quite useful, but you are kind of going in your head as well, going, okay, so I'm multiplying it. Oh, if I was multiplying it by a negative, it's going to reflect. Okay, it's stretching. If I'm going to add something at the end, it's going to move it up or down. So if I add a positive, it's moved up. And for the hyperbola and the exponential, those are the ones with asymptotes. Draw those asymptotes first. You'll remember to draw them for 1, and for 2, they're just so helpful so that you know where to draw your function. So yeah, hopefully that's helped a little bit with sketching of our functions. Let's move on to question 2. What have they got in store for us?